Yeah, see the syllabus, students. So the syllabus is divided into totally 6 parts. In that, the first part is taken the linear algebra. So in the linear algebra, we know that the basics of the linear algebra start from the class sixth class onwards. We are going to study this linear algebra. But by the step by step, we are studying up to real analysis. So up to real analysis, we are studying carefully in the linear algebra. So the in that we have the subtopics also. One of the subtopic is matrix algebra. In the matrix also, in the sensor, in the sensor or in the pie chart diagrams. So we are using the matrices. So next, this is the matrix algebra. All we are dealing with that. The system of linear equations. The linear means the one variable. Linear means the one variable. In the one variable or systems also we are using. So numbers and variables. So those all are including in the system linear equations. Eigenvalues and eigenvectors. Eigenvalues and eigenvectors are the this is related to the degree topic. So in the BTech or degree, you studied this clearly. So calculus, in the calculus part, this is newly introduced at the age of intermediate, I think. So in the intermediate only it is started. The function of single, the function topic is related to the 10th standard, but in intermediate also it is continuing. So next, that limit and continuity, it is also new to you. But in the degree standard means at the in your BTech or degree any degree standards, you studied clearly about it. And differentiability, mean value theorems, these are all the theorems related to indeterminate forms. The determined forms is clearly established, but indeterminate form means we don't know the values of the answers clearly, not clearly. So definite and improper integrals, we know the proper and improper. So we know all about the what is the proper function and what is the improper function and what is the proper value and improper value. Those all are there, but it is related to the integrals now. So double and triple integrals. Uh, in intermediate, we studied about the double integrals or one integral in mathematics, but in three integrals we studied in the physics. In the physical science textbooks or physical science problems, we studied triple integrals. That is volume integrals and surface integrals, volume integrals. Those are all including in these three integrals. And partial derivatives. The partial derivative means it is a dou symbol is there. So the dou symbol, we are dealing with the dou symbol and the dy dx. So that all are included in the partial derivatives. Total derivatives. The total derivative also same related to that. Taylor series. Taylor series is the one of the theorem. So the theorem is related to that. The series and sequences is there in our degree syllabus. So in the degree standard, we studied about the Taylor series also in one variable and two variables. So here also it is given two variables and one variable. Linear means the one variable, and quadratic and three thrice are these all are two and three variables. Maxima and minima. This is means limited values or boundaries or convergent values. So these all are comes in maximum and minimum. Fourier series also it is a degree, and gradient, divergent. These all are included in the calculus part. Differential equations is also one of the our topic. The first order equations. The first order equation means it is a d by dx means one time derivative. So first order it is included is a first means the single, with the single derivative we are dealing the problems. Higher order linear differential equations means we are doing with the triple or double differentiations, like that d square x by dx square, like that, with constant coefficients also. Euler-Cauchy equation, Cauchy theorem is also there. So we are all dealing with Cauchy sequences, series, all about that. Next, Laplace, these all same similarly. Now the next topic is complex variables. The complex variables means up to graduation level, we studied mainly about the real number systems only.
Adena.
Hello? Hello? Is there any doubt? Hello? Hello, sir?
Nothing. You go ahead, sir. You go ahead.
Yeah, okay,
you go ahead.
And complex variables. Yeah, okay, sir. Okay, thank you, sir. Complex variables. Complex variables means only real up to the real numbers we know clearly, but the complex number system is giving us imaginary numbers also. The imaginary numbers is giving us complex means it is not a clear value, it is included with the real value for stabilizing it. In that we have the topics analytic functions, Cauchy-Riemann equations, Cauchy integral theorems, means infinity series and finite series and infinite sequences, and 1 by np square, 1 by n square. These all are dealing with this. So probability and statistics. It is clear topic. We don't want to discuss about the subtopics because it is clearly mentioned that probability and statistics. The probability is we know that very clearly, and statistics also. For any data we can statistize that into the similar format. For the similar format only we can take the values and results. So for the for quick results we are using the statistics. Next, numerical methods. The numerical methods means we are mainly dealing with the numbers, so not a verbal, it is a non-verbal. So we are mainly dealing with the numbers. So now we have to discuss that these non-verbal topics only we have to discuss. Means non-verbal topics, if you are going to study, it is clearly understood by you. So I am going to start now. Equation of definite and improper integrals. We are given that equation of definite and improper integrals. I am sharing you that document. Please wait. Yeah, this is that. Our topic is that evaluation of definite and improper integrals. Is it visible, sir? Hello?
Yes,
Hello?
sir, we can see.
Yeah, okay. So evaluation of definite and improper integrals. First of all, we have to see that definite. Definite means we know if we are clearly say any word or any sentence, if you are understood it, then we say it is a clear. By seeing also, when we see the statistic diagrams, bar diagram or pie chart, we are easily understood that the ratio of the particular paddy or some grains, like that. If they are giving them food grains in a statistic box in the pie chart, when we have saw that, we clearly said that how much ratio it is dividing. So that is said to be the definite. So definitely means clarity and clearly it is giving the results. So that is the definite. And improper integrals, we know that proper and improper. What is the proper function and improper functions? So our fractions also proper and improper. So what is the proper and improper means? The proper, we said that f of x is less than g of x, then it is said to be the proper. And the improper is that f of x is greater than g of x, means the above value, the numeric value is greater than the denominator value, then it is said to be the improper. So improper means it is not giving fine fine value or numeric value, it is giving some point values or zeros, something like that. So it is, and it is related to the integrals now. So these two are related to the integrals. It is only some more difficult, only some. So some more difficult to understand what is it mean. By studying these definitions and types, we get some clarity. But after seeing the questions only, we fully cleared it is. So it is the topic of integer calculus. We know that the integrals are all comes under calculus part only. In that integrals means integral calculus part only, integrals covered. In that partial derivatives, integrals and definite and indefinite integrals are comes under integral calculus. Given one function, every time the definite integral should be in the format of integral a to b f of x dx. So the format should be in the format of a to b. These a b are the limiting points, we said that. So when given limiting points, then those integrals are said to be the definite integrals. Why? Because means when we have solved those definite limited integrals, we get some accurate value. For suppose 1, 2, 3, those numeric values we get from only definite integrals. When the limit points are given, then only we get the accurate values. In that, yeah, by seeing this function, yeah, integral a to b f of x dx, we can say it is improper proper. How can we say? So the three, yeah, 2 is given here. Integral is said to be, here it is a function equation 1. Integral 1 is said to be improper. When it is improper means given two definitions or given two hints. Two hints are given here. The first hint is that either A or B is infinite. That is, infinite means not defined. Not defined is the symbol. This is the infinite symbol or not defined symbol. Next, the second one is f of x is unbounded at A or B, means the value is infinity. We know that bounded or unbounded. Bounded means it is a convergent function. We get limited points. Limit points means 1, 2, 1, 3. 1, 3 are the limit points. In between 2 is there. 1, 5 or minus 10, 15. Those are the limit points. Means there is a boundaries. So that is called bounded functions. But when unbounded is there is no boundary. When there is no boundary, it is called unbounded. So we get, what is unbounded means we don't know. Then we don't know. In the mathematics we clearly said that it is infinity. We are dealing with the number. That's why when we don't know, we didn't say that we don't know. We said that it is infinity. That's it. Next, here the types of improper integrals is there. The first type is in the format of integral a to infinity f of x dx. It is a to infinity f of x dx. Here infinity is there. By looking this, we say that it is improper. Why it is improper? We know either a or b is infinity, then that function, integral function, is said to be improper. Here we saw that infinity, so that infinity is said to be the improper. Next, here also in the denominator or in the lower limit, it is given that infinity. In the lower limit also we get infinity. It is also treated as improper integrals only. Next, here it is integral minus infinity to plus infinity. We call it is a minus infinity to plus infinity. When we get the 1 infinity also, it is a improper. When we get two infinities also, it is treated as a improper. Next, where f of x is bounded in given integral, it means the function is bounded. Bounded means, for example, 1 by 1 plus x square. 1 by 1 plus x square is the bounded, but the limit points are 1 to infinity. If I given the function like that, integral 1 to infinity f 1 by 1 plus x square dx. In this, infinity is there. That's why we treated it as a improper. But the function is given 1 by 1 plus x square, means it is a bounded function. So that is a one type. And the second one is that integral a to b f of x dx there. So we are clearly given that limits are finite. Finite means limits have the a b. So particularly values a b is given. But f of x dx, the value of the f of x dx is, the function value is infinity. When the function value is infinity also, it is treated improper function. When the limit values are so infinity, it is also treated like it is improper. Next, we have to see that some convergency type and divergency type. I already told you that in the boundary, bounded means I told you convergent. So what is a convergent and what is a divergent? So see that integral a to b f of x dx is finite value and unique, then it is said to be convergent. Here clearly mentioned that integral a to b f of x dx value, when the integral a to b f of x dx value is 2, 3, 4 finite. So when it is finite and unique value, it is said to be the convergent. When it is not, it is said to be the divergent. Simply that's it. Next, integral 0 to infinity f of x dx is equals, we can write it is in the format of limit x tends to infinity. We know that we already studied limits, so that's why we know that by removing of this upper limit, we can put limit extends to infinity. Limit extends to infinity integral 0 to x f of x dx. Finite and unique when it is finite and unique when it is said to be the convergent. Next, see the question. By seeing definitions, we get some clarity, only some more clarity. But when we solve the problems, we get clear about doubts and we get some clarity about that question or about the topic. So first, see that first question. Test the convergence of integral 0 to infinity e power minus x dx. This is the question. Tell me, is it proper or improper? Anybody? Can you tell me, is it proper or improper? Your questions is like this only, Amma. Can anybody say? Am I audible? Are I audible to you? Hello.
Yes, sir.
Are you hearing
Audible,
me?
sir. Yes, sir.
Yeah. What is the function? The function I am giving that integral 0 to infinity e power x dx. Is it proper or improper? Choose anyone, proper or improper. If it is wrong, also no problem, Amma.
Improper, sir.
Yeah, it is improper. Why it is improper means I already told you that when the limit points, one of the limit point is infinity, it is that function is treated as improper. So it is improper. See, by the limit definitions or by the limit conditions, we know that limit we can write the limit point in the denominator like limit extends to infinity. Limit extends to infinity integral 0 to x e power minus x dx. This is the condition. What is the formula for integral e power x? These all are basics. When you know these all basics, then only you get proper idea about the questions and about the calculus part. Without this basic understand or basic key points, you can't do anything. What is the integral e power x dx? What is the formula?
E power x.
Yeah, e power x. Thank you. Next, limit extends to integral 0 to x e power minus x. When we have to take the minus x, we get that minus e power minus x. So this is the, yeah, right. Next, limit points we can write here 0 to x. We are clearly mentioned here. We know that when we put 0 here, e power 0 or anything power 0, we have to take 1 power 0, 2 power 0 or x power 0, anything power 0, it could be 1. Similarly here also e power 0, it could be 1. In the place of x we put only x, and after applying in x extends to what is given here, infinity, extends to infinity is given, so that's why we have to put here infinity, e power minus infinity. We know the problem, or we know the formula. Limit extends to infinity e power minus infinity is equals to 0. E power minus infinity, limit extends to infinity e power minus infinity, or limit extends to infinity e power minus x, so that is 0. Similarly here also e power minus infinity, the value of e power minus infinity is equals to 0. E power plus infinity, e power plus infinity is the infinity, and e power minus infinity is the 0. Next, plus 1 is there, 1 is a numeric value and constant value, we put it is only. Next, it is 0 plus 1. What is the 0 plus 1? 1. So 1 is a finite. Why? Because finite it is, we know the numeric, it is a single constant value. That's why it is a finite and unique. So we said that it is a unique. So that's why it is unique. Next. See the second question. Same similar to that first question only. Integral minus infinity to 0 e power x dx is equals to limit x tends to minus infinity. Integral x to the x tends to x to 0 e power x dx. Same similarly. We know that integral e power x is a e power x. Yes, e power x. Next. But we have to take here x tends to minus infinity. We know that e power minus infinity is the 0. That's why here also we get that 0. 1 minus 0. So we know that 1 minus 0 is the 1. 1 is also unique and finite. It is also convergent. Next. Up to now only the first question is that upper limit is the infinity. And the second question is that lower limit is the infinity. And the third question is that two limit points are infinities. Minus infinity to plus infinity. The integral part should be taken as minus infinity to infinity, and the function is given clearly 1 by 1 plus x square dx. So we can write it is a dx by 1 plus x square. Next, we know that 0 is the turning point. From minus, if we have to take that minus 1 to 1 as a limit points, we can divide those limit points into two parts. One is the terminating point is taken as a neutral. So neutral is a terminating point. So in between minus infinity to plus infinity, the terminating point or neutral point is 0. That's why we have to take that minus infinity to 0 d by 1 plus x square plus integral 0 to infinity dx by 1 plus x square. This is the one of the notation in definite integrals. Next, limit extends to infinity, integral extends to 0 dx by 1 plus x square plus limit y tends to infinity. Why we have to take here y tends to with the confusion of the x, that's why we have to take here y. Next, we know that clearly formula for integral 1 by 1 plus x square dx. What is the formula for integral 1 by 1 plus x square dx? Can anybody say? What is the integral 1 by 1 plus x square dx?
Tan inverse.
Or what is the d by dx of tan inverse x? Yeah, clear. Good. So it is a value formula for tan inverse x. Integral x to 0 dx or 1 by 1 plus x square. We know that tan inverse x. When we are simplify this one, we get that minus infinity. Tan inverse minus infinity. What is the tan inverse minus infinity means? In the tan, we know that in the tan it is at the 90 degrees. The tan where it is 90 degrees, we get that infinity value. So here also same. We know that pi by 190 also we divide as pi by 2. Why it is pi by 2 means it is radian format. Every trigonometric function we have to take in a radian format. So pi is said to be the radian. Pi, one single pi is equals to 180 degree. So we have to take that 90 degree. That's why we have to take that pi by 2 means 180 by 2. It is a 90. Next, pi is also 180. 180 is the specific value. So the specific value is treated as a unique value. So when it is unique, it is a convergent. Next, these all are the convergents. We clearly said that. But when it is divergent, we don't know. So for that, we have to see that one question. Fourth question is there. Integral 0 to infinity e power x dx. I already told you we can write limit points like this only. Limit x tends to infinity, integral 0 to x e power x dx. So we know that clearly integral e power x dx formula is e power x. So it is e power x. Limit x tends to infinity e power x. The limit points are 0 to x. When we are substituting limit points, upper limit minus lower limit. Upper limit is x. In the place of x, we put x. E power x minus e power 0. What is the e power 0? E power 0 is the 1. So e power 1. Next, in the place of x, we put infinity. It is e power infinity. So what is the e power infinity? E power infinity is the infinity. I already told you just now. E power minus infinity is the 0. and e power infinity is the infinity. So here we get e power infinity minus 1. E power infinity is the infinity. What is the infinity minus 1?
Infinity.
Infinity only. Why? Because we don't know that. The value we don't know. That's why we said infinity. With the infinity, we are subtracting or adding. We don't know anything. So that's why we simply said that it is infinity. When we get infinity, that it as divergent. So one more question is also there here. Similarly, above, it is also getting divergence. Yeah, any doubts? 5 more minutes we have. Anybody? Students, anybody can ask any doubt. About syllabus or about any calculus part or numeric part. If you get any doubt, your brain is functioning. If you not get any doubt, you didn't understand or you completely understood. That is a difference. Is it clear? Are you understand?
Yeah, my student will never talk because they have a
Okay, okay, sir.
one word that when they get
Okay.
crack the gate, then only they will talk. ప్రామిస్
Okay,
చేస్తున్నారు.
good, good.
లెట్ మీ సి ఎన్నాళ్ళు ఇట్లా మౌనంగా ఉంటారో చూస్తాను నేను కూడా. దీస్ ఆర్ ద డెమో క్లాసెస్ సో దట్ ఐఎమ్ కీపింగ్ కామ్. ఐ విల్ మేక్ దెమ్ టాక్. అండ్ థ్యాంక్ యూ సో మచ్ ఫర్ యువర్ వాల్యుబుల్ డెమో అండ్ వాల్యుబుల్
అట్లీస్ట్
టైం.
మీరు వేరే వాళ్ళు
యా
స్టూడెంట్స్ ఎప్పుడైనా ఒక లెక్చర్ ఇస్తే మీరు అట్లీస్ట్ ఆ లెక్చర్ కి రెస్పాండ్ అవ్వాలమ్మా. ఐ మీన్ ఇట్ ఈస్ గుడ్ ఆర్ బ్యాడ్ ఆర్ అండర్స్టాండ్ అన్నప్పుడు అట్లీస్ట్ మీరు అర్థమైందో లేదో అయినా సరే మీరు చెప్తే ఆ లెక్చర్ కి కూడా అర్థమవుతుంది అసలు మీకు అర్థమైందా కాలేదా అని. మీరు ఒకవేళ మీకు అర్థం కాకపోయినా మీరు ఆ టైంలో ఒకవేళ ఫియర్ వల్ల అబద్ధాలు చెప్పినా సరే బట్ ఏదో ఒక రెస్పాన్స్ అనేది మీరు ఇవ్వాలమ్మా.
యా ఫ్రమ్ భాస్కర్. ఎస్ సార్, అండర్స్టూడ్. Okay, fine. Thank you so much, Mahesh sir. Thank you for your valuable
Yeah, okay,
demo,
sir.
and I will end the session with a small breakthrough to the topic. And all of you,
Okay.
and are you ready to learn tables up to infinity in just 10 minutes? Are you ready?